Factoring special products has to do with certain polynomials that are only two terms that can be broken down into two different factors. So the first one we're going to do is called difference of squares. And it's called that because just like it sounds, it's going to be subtraction of two things. So, and it's going to be two things squared. A squared minus b squared. So a squared minus b squared ends up being, let's change this to, I was debating how to write my a's. Keep it like this. A squared minus b squared. It is a plus b, a minus b. And kind of why that is if I FOIL this out, first would be a squared, my outer would be minus ab, inner would be a plus ab, last would be minus b squared. So see that minus ab and the plus b cancels out, and I'll be left with a squared minus b squared. So that always happens with a difference of squares. So like if I have x squared minus 25. If I want to rewrite this, x squared minus 5 squared. This is saying that a is x, b is 5. So when I rewrite the factored version, every time I see an a, I'll write x. Every time I see a b, I'll write 5. So x plus 5, x minus 5. Lost my pen. And if I FOILed that out, I would get back to my original x squared minus 25. Okay, how about 9x squared minus 49? So now I have a number in front of the x squared. So sometimes it helps use parentheses. Something squared minus something squared. So in the first set of parentheses, that should be 3x. 3x squared is 9x squared. 7 squared is 49. So that means a is 3x and b is 7. So this is going to break down to 3x plus 7, 3x minus 7. And again, FOIL it out, that should work. Okay, so that's difference of squares. The next ones actually we'll talk about are sum and difference of cubes. Sum of cubes and difference of cubes. So the sum of cubes, a cubed plus b cubed, is a plus b times a squared minus ab plus b squared. And then the difference, a cubed minus b cubed, is very similar. It's a minus b, a squared plus ab plus b squared. A mnemonic device used to remember the signs of this, it only tells you what the signs are. It says that the signs are the same, opposite, and then always positive. So this, as long as you know the first factor is a binomial, a plus b or a minus b, the same sign as whatever, if it's a sum or difference of cubes. And then the next part you would have to know is a trinomial, a squared, ab, and b squared. And then the signs that fit in is the opposite sign, and then always positive. So just a way to keep track of what the signs should be. So let's say, for example, I have x cubed minus 216. Or let's rewrite this, x cubed minus 6 cubed. So every time I see a, I'm going to write x. Every time I see b in my formula, I'm going to write 6. So since this is a subtraction when I'm looking at my second formula, so a minus b, x minus 6 times x squared plus x times 6 plus 6 squared. And then I'll just kind of clean this up. X minus 6 looks good. Then my trinomial I can clean up a little bit. X squared plus, we usually write that as 6x. And I can actually do 6 squared, so I would do that, 36. Okay, so that was the difference. Let's do a sum. 8x cubed plus 27. So this is another one, coefficient of x cubed. There's actually a number, so it helps to, let's use some parentheses on this one. 2x cubed is 8x cubed, and then 3 cubed is 27. So another thing before we get started on this one, sometimes it helps to make a little chart. Like here's my numbers. If a is 1, 2, 3, 4, so forth, what is a squared? And what is a cubed? Because those are the numbers we're going to keep seeing. 1 squared is 1, 1 cubed is 1. 2 squared is 4, 2 cubed is 8. 3 squared is 9, 3 cubed is 27. 4 squared, 16. 4 cubed, 64. Dot, dot, dot. To kind of just keep track of what those numbers we're going to see with these special products. Okay, so back to this problem. A is 2x and b is 3. So this is a plus, so I'm looking at the top line. A plus b, 2x plus 3. And then a squared, so 2x squared, that whole thing squared, minus 2x times 3 plus 3 squared. So again, I'm going to clean it up. 2x plus 3 looks good. 2x in parentheses squared is 4x squared, minus 2x times 3 is 6x, plus 3 squared is 9. So that's my answer. If I want to multiply these ones out, distribute the 2x to everything, distribute the 3 to everything, we'll see things drop out and we'll just be left with my original 8x cubed plus 27. So not a bad idea to check that out, give that a try, make sure it works out.